Hi, everyone. I'm Maggie Mascarenas. I'm the Policy Program Manager here at Sustainable Agriculture and Food Systems Funders. We're really appreciative of you joining today's webinar, Pathways for Industry and Agriculture to Reduce Nitrous Oxide Emissions from Synthetic Fertilizer, co-hosted by SAFSF, McKnight Foundation, the Regenerative Agriculture Foundation, Climate and Energy Funders Group, as well as Health and Environmental Funders Network. As you can see, we're recording today's session and we will be sharing out the recording as well as the slides from the presentation with anyone that registered. And also, please feel free to drop any questions that you have in the chat as we go. We'll have some direct time for Q&A later today. But with that, I'm going to pass it over to Dolkar to get us started today.
Thank you, Maggie. And while Angie's pulling up the slide, I just want to start with saying thank you. Thank you to each one of you for joining us for this webinar. My name is Tenzin Dolkar. I'm a Senior Program Officer with the McKnight Foundation on the Midwest Climate and Energy Program. And I have the honor of introducing the four speakers that are on the webinar today, who are also the key contributor to the report. And there are many more folks who have really worked on the report, who have given us great ideas. They're all acknowledged on the report. We will send the webinar's recording, not the Q&A section. We're going to record till the Q&A session. We'll share the slide deck, and we will also share the full report in the report out. So the four and really, of course, thank you to our co-sponsors, Sustainable Agriculture Funders Network, the Regenerative Agriculture Foundation, CEFG, and HEFN, in addition to McKnight Foundation, who's hosting this webinar. And next slide. And so everyone, you saw this in the notice out. The four main speakers for the webinar today are Mike from WRI, Courtney from EIP, Scott from Environmental Working Group, and Patrick from Rocky Mountain Institute. So incredible gratitude to each one of the speakers who are here with us today. And here, this is where I'm just going to take a moment to say, it's really hard you can have a very robust discussion when you're in person. It's really hard to duplicate that level of interaction virtually. And so I'm going to ask for the grace. If you could just be fully present during the presentation and webinar, that will make for a much more reachful discussion and Q&A session. And also, I will say it's really hard to somebody who works in the foundation to, always have back-to-back meetings. And sometimes I find myself checking emails during my online virtual calls. So I'll say, if you can be fully present during the webinar. Next slide, please, on the report. And so I will say at the McKnight Foundation, I started here 4 years ago, and I've had the privilege of launching the Working Land strategy. And the design of our grant making at McKnight Foundation really centers farmers as climate leaders. We wanted our grant making to be rooted in power building in rural communities and really uplifting the work of farmers as key climate solutions leaders. And one of the challenges we saw in the agriculture sectors as we proceeded over the years, and Michael Roberts, who you will hear later on, as the two of us were building the portfolio and we're engaging across the Midwest states, one of the things we realized is, unlike the other sectoral strategies of climate, we didn't have a shared emissions reduction goal across the field. And so this report in one of the shape was meant to address that gap that we saw. And so, a year ago, I would say more than a year ago, we brought together experts from across the field, nationally and locally, and we wanted to take a look at the emissions from the agriculture sector. Methane and nitrous oxide are complex. The solutions are complex. They're complex and not easy, but not unknown to us because all of us have worked on it in various shape or form. And we wanted to just ask, could we actually do something about the emissions? And one of the more specific one we wanted to take a look at is the nitrous oxide emissions from the agriculture sector. And together, the group co-created high-level emissions reduction goals that we felt were ambitious enough, but very, very achievable because we knew the solutions were happening across the field, that we could add it up to amount to something that was much more meaningful together. And so from that working group and that convening that happened in the summer at McKnight, there were a small group of us who then worked on the report that is now in front of you, and that is also downloadable on the QR that you are seeing. And as a climate funder, I will say I'm very, very excited to see the broad range of solutions in this report. The report specifically focuses on synthetic fertilizer and its role in driving agriculture emissions, more specifically nitrous oxide emissions, both in the application and production. The report is meant to spark dialogue and encourage common sense solutions. And I think as a funder, like what I can say, as philanthropy and in this field, we can do what we do really well, which is sharpen and co-collaborate in defining the strategies that we want to collaboratively work on to address the emissions. And we're sharing this report with all of you. This is one of the many sort of the sharing of the report that we're hosting. And as I've hosted each one of the session or learning session in collaboration with Regenerative Agriculture Foundation and others, what I have often said is agriculture feels like a story of thousand seeds in terms of solutions, and each one of us can plant a seed. And I'm planting that seed with you and asking each of you to help us figure out the transition of cutting nitrous oxide emissions from synthetic fertilizer. And how we do it is making sure farmers and rural communities thrive and benefit from this transition and not get harmed by it. And so with that said, I will turn it to the first speaker, Scott.
Great. Thank you so much, Dolker. And let me see if I can add a little fertilizer to that seed. Haha. And let me just also thank Michael and Mark as well, and all of you for joining us today. I'm going to start by reminding us why nitrous oxide emissions matter so much, and they matter because emissions from fertilizer production, as well as from the use of fertilizer in farming, is the largest source of greenhouse gas emissions from agriculture and account for nearly 80% of all U.S. nitrous oxide emissions. And as this slide shows you, the U.S. is already the world's largest producer of synthetic fertilizers, and domestic production is expected to quadruple by 2030. Next slide, please. And as Dolko was saying, until now, our movement really lacked a galvanizing goal, a North Star, a target for emissions reductions of nitrous oxide emissions reductions. And thanks to McKnight bringing together NGO leaders and farm organizations together, we have set three goals, and they're captured in the report in more detail. But you can see them in front of you. Reduce nitrous oxide emissions from domestic fertilizer production by 75% by 2035, achieve net zero greenhouse gas emissions from domestic fertilizer production by 2050, reduce total nitrous oxide emissions from fertilizer production and application in the US by at least 50% by 2050. And the good news is that these goals are not only ambitious, but they are achievable. And you'll hear more in a moment from some of my colleagues about why they are achievable. Next slide, please. And certainly everyone on this call knows agriculture now accounts for about 10% of all U.S. greenhouse gas emissions. What you may not know is that agriculture's share of U.S. emissions will likely rise to a third or more of all U.S. greenhouse gas emissions by 2040 as other sectors, especially energy and transportation sectors, reduce their emissions and agriculture's emissions remain steady. So as energy and transportation emissions fall and agriculture emissions stay steady, agriculture's overall share of emissions in the US will increase from today about 10% to about a third, which would make the agriculture the nation's leading source of greenhouse gas emissions. Next slide, please. And as you also know, nitrous oxide emissions, not methane emissions, account for the majority of emissions, and these emissions are really powerful, 300 times more powerful than carbon dioxide emissions. These facts that agriculture may soon be, not only that agriculture may soon be the nation's leading source of greenhouse gas emissions, but that nitrous oxide emissions are the largest share of those emissions, that they're 300 times more powerful than carbon dioxide emissions, remain largely unknown to policymakers, opinion leaders, even NGO leaders. But that is something that philanthropy can help us change. Next slide, please. Um, and most of these solutions, most of these emissions as you probably imagine, come from farm soils. And as this series of maps shows, these emissions are growing. But some are also from not just from the application of fertilizer, but from the production of fertilizer. And these are among the easiest to reduce. And I will throw the mic to my colleague, Courtney.
Thanks, Scott. I'm Courtney Bernhardt. I'm the research director at the Environmental Integrity Project. I'm going to speak a little bit more about the public health and climate impacts of current synthetic nitrogen production in the U.S. You can go to the next slide, Maggie. So I'm going to introduce you to this plant on the screen. This is the CF Industries Donaldsonville Nitrogen Complex in Donaldsonville, Louisiana. It's in Ascension Parish between Baton Rouge and New Orleans, an area also known as Cancer Alley. This is the largest synthetic nitrogen fertilizer manufacturing plant in the world. And I'm going to share the specific pollution impacts of this plant in a moment, but I'd like to provide you some background information so you can put this into context. In the US, we currently have 36 plants that make nitrogen-based synthetic fertilizers like ammonia, urea, ammonium nitrate, and ammonium sulfate. And as Scott mentioned, based on proposals that we've been tracking, that the amount of fertilizer production in the US could quadruple by 2030 if all the proposed expansion and new plants are built. In 2023, the plants that existed reported emitting around 42 million metric tons of greenhouse gas emissions. 82% of that was carbon dioxide. The other 18% was nitrous oxide. And that percentage may seem small, and on a mass basis, it may seem relatively small, especially compared to the amount coming from fertilizer use. But remember that nitrous oxide is stubborn. It's a stubborn molecule, and it also depletes the ozone layer. So there is urgency in reducing emissions from most sources that emit it, especially when it's achievable. Nearly all of the nitrous oxide emissions from the fertilizer production process comes from the manufacturing of nitric acid. And nitric acid is a key ingredient that's needed to make ammonium nitrate fertilizer, sorry. The good news is that cost-effective technology, exists to reduce nitrous oxide emissions by 70 to 90%, but no technology-based standards are in place to require installation. And I'll get more into this shortly. Maggie, could you go back to the Donaldsonville plant real quick? Thanks. I want to dive into the environmental health impacts of fertilizer production. First, fertilizer plants are petrochemical plants, and not surprisingly, they have a massive climate, public health, and environmental footprint. In addition to nitrous oxide, they emit a lot of air and release a lot of water pollution. Many are in communities with environmental justice concerns, and they bear the brunt of the pollution from manufacturing. The types of air pollutants they emit are fine particulates, nitrogen oxides, and as well as hazardous air pollutants and ammonia itself. They're responsible for chemical leaks and accidents that have not only closed schools or evacuated workplaces, but they've killed workers and caused residents to shelter in place or evacuate. And just last week, there was an explosion at a CF Industries plant in Yazoo City, Mississippi, that caused folks to shelter in place and evacuate for quite a long time. And on the water side, these plants release large amounts of nitrogen and ammonia into waterways that can kill fish and create dead zones, as they also release metals and salts that wreak havoc with the health of waterways. And on the nitrous oxide front, I want to point out the fact that discharges of nitrogen to waterways feeds the nitrogen cycle and can contribute to the release of nitrous oxide from aquatic systems. And once it gets in the water, it's much harder to measure and monitor and prevent those emissions. So much of this pollution is unfortunately legal. Some of it may be illegal. And this is because federal pollution standards for fertilizer facilities are very outdated. The water pollution control technology standards date back to the 1970s. And it's been over 10 years since the new source review standards for nitric acid production were updated. But even so, a number of plants are still struggling to meet the weak limits that they do have. For example, 18 of the plants that we examined in this report were flagged as EPA as having been in violation with the Clean Air Act at least one quarter during the past 3 years. So back to Donaldsonville, and then I'll move on. This plant is the largest source of greenhouse gas emissions in Louisiana. It emitted around 9 million metric tons of carbon dioxide equivalents in 2023. Of that, 1.7 million metric tons were nitrous oxide, and that accounted for more than 20% of the total nitrous oxide emissions from all fertilizer plants in the US. And that's huge. But it's also an opportunity because installing controls at this plant could make a really large dent in overall emissions. In addition to nitrous oxide and greenhouse gases, the plant emitted over 3,500 tons of health-harming air pollutants and 337 tons of hazardous air pollutants into the air. They also reported hundreds of accidental chemical releases between 2006 and 2023, and that number of incidents has increased in recent years while the plant is expanding. On the water side, the plant dumped more than 3 million pounds of nitrogen into the Mississippi River in recent years. So this is just a snapshot of what communities are up against and the public health impacts and environmental impacts from synthetic nitrogen production. But this facility isn't an exception, and even more of these plants are on the way. So next slide. So this is a map that shows where plants have installed nitrous oxide controls and where they're still lacking. About half of the plants in the US have installed controls and half still need to make progress. So this is really good news. Controls are being used in some places, and those controls are proven cost-effective, and they could dramatically reduce nitrous oxide emissions. Next slide. These are examples of some of the technologies that can be used to reduce nitrous oxide. One thing to point out is that some of these controls can also be used to reduce emissions of regulated pollutants like nitrous oxide or nitrogen oxides, which contribute to ozone formation, and it's also a lung irritant. So, next slide. So as I mentioned, they could reduce these technologies either in combination or alone could reduce emissions by between 70 and 90%. For example, controls were installed at a fertilizer plant in Kansas that caused nitrous oxide emissions to drop by more than 99%. They fell from around 278,000 metric tons to just 106. And then on the flip side, half the plants are not operating with modern pollution controls, including that CF Donaldsonville plant that I talked about. Only one of the 4 manufacturing units at their plant that make nitric acid have installed those controls. So, and before we move on, I want to make sure that we note that on the water side, we do know how to remove nitrogen and toxics from industrial wastewater. And these technologies have been around for decades and can slash harmful nutrient and metals discharges by as much as 50% or more. Next slide. And I promise I'm wrapping up shortly. But So the report mentions 3 ways we can help close the gap between the status quo and what we know is technologically possible. First, we have to address the elephant in the room. The most efficient way to reduce climate and local pollution from the fertilizer industry is for EPA to set federal pollution standards under the Clean Air Act and Clean Water Act, which are long past due. But we know that's not going to happen under this administration, and it didn't happen under the Biden or Obama administrations either. It is possible for states to take action, but we don't expect that to work everywhere. These plants are located like in Texas and Louisiana, where the politics just are not favorable. But just because EPA or states won't act doesn't mean that we can't. And the existing laws on the books actually give us a lot of tools to clean up the fertilizer industry. So in EIP's view, this is what action looks like in this moment. First, the public has the right to participate in permitting decisions for these facilities. On the air side, if companies want to expand or build new pollution units, they have to go through a process under the Clean Air Act called New Source Review. I'll spare you the details, but the upshot is that communities can advocate for modern pollution controls during these permit proceedings. For existing pollution units, communities can weigh in on operating permits and demand better monitoring and reporting to ensure that companies are accurately reporting their emissions. And these kinds of requirements help spotlight noncompliance with the law. On the water side, again, folks can participate in discharge permitting proceedings and advocate for modern wastewater pollution controls. And this is actually a requirement under the Clean Water Act. Second, our environmental laws give ordinary Americans the right to enforce the law in federal court against companies that go past their pollution limits when the government doesn't act. And these actions are called citizen suits. They're actually pretty rare. They're resource intensive, but they can have a lasting impact and can bring immediate relief to communities that are facing the burden of pollution. They also build a stronger kind of shadow docket and create a record that a more favorable EPA could act upon quickly. And last but not least, it's critical that we ensure that communities can claim their rights under environmental laws and that they're able to participate in permit proceedings and citizen suit enforcement. Through those negotiations, they can negotiate for tighter pollution controls, for the installation of nitrous oxide technology or control technology, as well as other improvements. So I'm going to pass it to Patrick, who's going to tell us more about other technology on the horizon.
Thanks, Courtney. I think we can probably move into the next slide and just dial in a little bit on some of the kind of imperative for action at the moment around this. And, this engagement obviously has a very direct relationship to the agricultural emissions profile and to all the areas that Courtney and Scott have covered already. But I think it's also very worthwhile to zoom out a little bit and understand that if we look at a 2030 to 2050 timeline, we're seeing an absolutely enormous escalation in the volume of expected production of ammonia and related derivatives. And if you look at this chart, you'll notice that we're not in it projecting a growth of fertilizer at all. What we're seeing is a massive increase in maritime fuels and shipping exports related to production. So that capacity at one point in time, I think in the last number of years, there were a proposed 29 million metric tons of ammonia capacity to come online in the Gulf Coast alone. This creates an imperative around immediately emissions reduction, taking steps on technology interventions that can remove the associated emissions, and all the measures that Courtney ran through just there around existing facilities, applying the technologies that are mature today to reduce and remove nitrous oxide directly, but also to ensure that we are not setting ourselves up for an escalating problem in general. So maybe if we move to the next slide. This is not quite the quadruple target. I think this is a more kind of concrete, closer to final investment decision projection. But and some of the structure is slightly gone in terms of the conversion here. So apologies, the chart doesn't look quite exactly right. But currently it's around 16 million metric tons today in the US alone. We've seen capacity moving towards about 100, or sorry, increasing by about 110%, so up to about 33 million metric tons by 2030. This is linked again to those shipping, energy export carrying capacities that you kind of see in the chart on the right. And while we've seen disruption with the International Maritime Organization negotiations a couple of weeks ago being paused, there is still likely a substantial increase in the capacity of production that is going to emerge. So this is twofold a factor effect, and it is part of the reason for the concentration on the production side as well, which is that while farmers buy fertilizer, the expansion of these markets without the additional capacity starts to put pressure back on farmers. And as such, we have to look at ways to avoid both economic and associated pain, but we also have to ensure that we're getting the highest quality standards with any new facilities or any level of production that comes online. And there is a domino structural risk when we start to blend sectors. And this is something that goes even beyond ammonia or chemicals or hydrogen or anything else. It is about the fact that these sectors and new demand pools creating pressure that leads to rapid deployments and some choices around kind of supply or contracting structures, and that creates pain. So to the point, and maybe if we move to the next slide just briefly, our conventional production pathways for these types of molecules today is linked to the Haber-Bosch system. The Donaldsonville facility that Courtney highlighted is a large Haber-Bosch facility with associated kind of derivative production systems that is powered by natural gas, so methane, upstream methane emissions associated with it. In separating the natural gas, it has CO2 emissions in it. In the nitric acid production, it has N2O production associated with it. And while the electrolyzer technologies here on the right address the CO2 emissions and remove the methane emissions, we have to start looking at alternative technologies as a pathway to remove nitrous oxides emissions in production. And there are opportunities to address these emissions in production. And again, just to say, this isn't about producing more, this is about producing better. And as these chemicals kind of are developed and produced, understanding the risks, understanding the necessary deployments, understanding what is the appropriate technology pathway where production is necessary, but also fundamentally that we are putting in place the appropriate standards and controls to ensure that the externalities and the harms that have been highlighted are avoided in full extent. So to the point, and the point of this chart, we have technology pathways that are maturing that avoid many of the harms and the waste streams, as well as many of the kind of, for instance, the kind of shelter in place hazards and things like that were highlighted earlier. There are solutions both on the technology side and also in our management and structuring of these things. So with that, I think I can pass on to the next person if we go to the next slide. I think it might be Mike or Scott up next.
Yeah.
Yeah, thank you, Patrick. Hi, everyone. I'm Mike Badzimorowski with the World Resources Institute. Next slide, Maggie. So the Environmental Working Group where Scott works, they've done an analysis recently where they looked at continuous corn acres in the Midwest and found that from 2016 to 2024, 15 million acres were in continuous corn, meaning that it was at least 3 years that it was planted in corn. Corn is a extreme user of nitrogen. It requires a significant amount of nitrogen input to get the yields that we are receiving. Um, Next slide, Maggie. So, kind of the big elephant in the room is corn in the sense that the majority of our emissions from nitrous oxide in the field, which is kind of what we're here to talk about, is largely derived based on the rate that we're applying. Corn just requires so much nitrogen to produce that it's inevitable that some of it is going to be released as nitrous oxide. So part of that previous slide was in essence of thinking about a transition that is fair for the farmers, but thinking about how do we transition away from just 15 million acres of continuous corn, which is probably likely rising as well, just with the current demand structures for corn. Of which, if you're not familiar, I'm sure many are aware at this point, but about 40% or so is gone to putting in your car engine, or biofuels is what they're known as, um, or another 40% going roughly to cows or cattle for feed. So it's thinking about these structure dynamics of how are we using corn and how do we want to see our future. So one of the main things that we've looked at as opportunities to reduce nitrous oxide in the field is changing nitrogen application timing. Now, the majority of the reductions that could occur from this is there's a significant amount of fertilizer being applied in the fall, where it has months to just sit there in the field and not be taken up by a crop. Now, cover crops ideally are trying to help soak up some of that nitrogen and be used for the cash crop later in the spring, but that doesn't solve it all either. So mainly trying to switch farmers that are currently applying in the fall to switch them to moving towards the spring to narrow that window of nitrogen loss is really key. Um, in areas that have irrigation use, water management is really a key thing for nitrous oxide. So for nitrous oxide to form in the field, it requires a certain amount of moisture in the field. Generally, the more moisture, the more nitrous oxide, until you get to like a flooded condition. Then it's moving into what's called dinitrogen gas, which is what our atmosphere is essentially made out of. So that is actually still a form of nitrogen loss, that a farmer is losing nitrogen. It's just not impactful from a greenhouse gas perspective. So kind of narrowing the area which is getting wet. In California, this is kind of seen as one of the main ways to reduce nitrous oxide emissions is to have more precision irrigation and minimize the amount of moisture in areas that the crop isn't. Another option that we've kind of highlighted a little bit is reevaluating crop choices and production locations. So we discussed about 15 million acres already in continuous corn. Planted this past year was around 95 million acres of corn, of which is, I think this next part is production locations. We're usually about 10 million acres go unharvested. One of the key things to look at is where are these locations of corn and other fields where there is continuous crop insurance claims, where there's probably very risky areas. One of the ways that I like to look at this is, near rivers, we have rain events that cause flooding of the rivers. Now, there are some areas where it's very frequently flooded by expansion of the floodplain, is what it's called. So if there is a often reoccurring flood, those areas are most likely being inundated, and the corn or whatever crop is there is most likely either having a real significant decline in yield or just not even harvestable, period. So I've like to call to action of a 2-year floodplain, meaning there's a 50% chance on any given year that it will flood as a way to potentially reduce risky areas. Um, Otherwise, there are other options for accelerating sustainable management approaches and looking at soil health practices, whether I mentioned like the cover crops and trying to soak up some of the nitrogen that's there in the fall, or just basic annual soil testing. It's often overlooked of very simple practices that a farmer can take, mainly because of costs. And helping farmers get to that point where they can rely on a steady source of income to test for their soil and know how much nitrogen is even there and how much do I need to apply for that next season. Thinking about manure, there's a lot of fields out there that are receiving manure but not necessarily getting the nitrogen credits, is what we call them, of they're still applying synthetic fertilizer at the same rate, but not discounting the manure that they put down. Making a lot of these things easier for farmers and more economical are really key to knowing our nitrogen management better. And next slide. And I'll pass this off to Scott.
Yeah, well, as you've heard from my colleagues, there are solutions that are available, but only if we choose to send the right signals to companies that are making fertilizer, right signals to farmers who are using fertilizer, and make the right investments, requiring off-the-shelf technology to reduce emissions, investing in new, better fertilizers, setting the right economic signals to farmers when they're making crop choices, including whether to grow corn in 3 or more consecutive years, investing in proven practices that can help reduce nitrous oxide emissions. All of these in combination, all these policy reforms in combination could help us reduce nitrous oxide emissions from fertilizer production by 75% by 2035 and reduce emissions from fertilizer production and applications by at least 50% by 2050. And I'll throw it back to Dolker. Next slide.
I'm actually going to invite Michael Roberts on my team to speak to this.
Sure. Thanks, Stoker. Hello, everybody. Michael Roberts. I use he, him pronouns and the senior program officer on the climate team at McKnight. So, as we can see, across the board, there are a lot of ways that philanthropy can invest to drive change on this issue. And so, no matter what kind of perspective you're coming from, there's a point of engagement that that can kind of move can help us move forward. And so, as we've heard, advocacy organizations, advocacy is not dead, in spite of what some might tell you. There's still plenty of opportunity to engage on state and federal policy frameworks, and I think I appreciate Courtney highlighting that there are still ways to engage the administration on existing rules and support groups that are doing that. Investing in new conservation funds. We can kind of see everything on the path. I mean, to me, I think what kind of based on what we've heard on this from this presentation, I think some key takeaways are we have to continue and deepen our support for frontline fence line communities. Share what we learned and knowledge. I think the closer that the more we can move on a lockstep set of goals around emission reduction in the nitrous in nitrous oxide emissions, the better we can be, and find collaborators. I mean, I really want to name kind of in this room. There are some great collaborators and folks working on it, and want to particularly name ClimateWorks for the amazing work that they're doing around agrochemicals, as well as who's not on the call, the Platform for Agriculture and Climate Transformation Pact is doing some really deep thinking as well on nitrogen fertilizers. This is an opportunity for us to collectively put a stake in the ground. I think it's not crazy for us to consider what it looks like to call for what a federal fertilizer efficiency standard would look like, or really explore and invest in modeling what a CAFE standard for nitrogen fertilizer emissions could actually look like. I think there's a lot of really rich opportunity, and I think in order to get there, I really want to invite us to move into Q&A and really give you a chance to engage with the speakers and us on what is kind of what is next for us as a field on this issue.
Thank you, Michael.